back here. We're in chapter 1, section 6, dividing integers today. So just a short little lesson on dividing integers, and then you're on your way today. Because you have done this before. So there's two possibilities when dividing integers. We can divide integers that have the same sign, or we can divide integers that have different signs. So let's start with the same sign. So way back in, third grade or second grade, you started to divide things like you see here. 8 divided by 4. And 8 divided by 4 is, everyone? 2. And it's just positive, isn't it? So we can fill in that quotient is what it's called. One of my least favorite words in math. It's not a word that we use in our everyday life. I mean, we use product in everyday life. And we use the total and the sum, those kinds of words, but quotient is just not a commonly used word, right? One thing you learned when you were learning about division, probably in 3rd and 4th grade's a really big division year for long division, right? Was you can kind of work backwards to check your work, right? You can take this quotient and multiply it to the divisor. 2 times 4 is 8. And that's called the dividend, the one that would go in the doghouse that you would divide into, right? So we can check our work by changing a division problem backwards into a multiplication problem. 2 times 4 is 8. Okay, let's see what happens with this. We have negative 9 divided by negative 3, and you think it is what? Gavin? 3. He thinks it's 3, so let's jot that down. We can do the same type of check now when we're dealing with negatives. This is really helpful. We can go and say, look at what we got. We got 3, the quotient, 3 times the divisor. 3 times negative 3 is? Negative 9. We work our way back up to that dividend, right? So it's like a little fact family, isn't it? So notice that when we divide a positive number by a positive number, we get what type of quotient? Positive. And when we divide a negative number by a negative number, we get what type of quotient? Positive. So if you have the same signs, then you're going to end up with a positive quotient. Okay, so how about different signs? Let's try this. We'll do the same thing. We'll try it and we'll check it, and then we'll know for sure what's going on when we have different signs in our division. Okay? So here we have 2 division expressions. Notice that the further you get in math, the more often you see division written as a fraction, and we don't see the little division symbol as often. You may see it, but not as often. Fractions are what we'll see. 14 divided by negative 7. What do you think, Aiden? What do you think?
What?
14 divided by negative 7. What do you think?
2. Or negative 2.
He's saying negative 2. Okay, so let's check it using multiplication. Negative 2 times negative 7 is? 14. So he's correct. How about this? Negative 21 divided by 3, Stuart?
Negative 7.
Good job. And when we check it, negative 7 times 3 is? Negative 21. So when we have a dividend that is positive being divided by a negative divisor, we get a negative. And we can even flip those signs and have the negative dividend by the positive divisor, and we still get a negative quotient, right? So when you have opposite signs like that, you end up with a negative quotient. What happens when we divide by 0? This is a really, really interesting thing. Jake?
It's 0.
Okay, let's see. 12 divided by 0. Here it is, here. 12 divided by 0, you're saying is, I'm going to rewrite it here. 12 divided by 0 is 0. Thumbs up if you agree. Seems logical. So if that's true, then we should be able to test it to prove it using our multiplication. So Jake, what is 0 times 0? 12? Oh, but wait a minute. Isn't it supposed to get us back to our dividend? Is 0 times 0 12? 0 times 0 you're saying is 0. So if 0 times 0 equals 0, then this is not a true statement. 12 divided by 0 doesn't seem to equal 0. So if it doesn't equal 0, what does it equal?
Nothing.
12 divided by, somebody just said it might equal 12, so let's try it. 12 divided by 0 equals 12. If that's true, we should be able to work our way backwards with multiplication, right? So 12 times 0 is 12?
Yeah.
There's no way you can ever get it. Okay, so we say that when you have an expression like this, it looks so easy. People think it's 0, but it never is. There actually is no value for it. It is undefined. That is what it's called, is undefined. You know what's interesting though, as we get in further into math, we can use undefined expressions to do stuff. We can graph with them, but we can't really say what their value is. If somebody says, what is the value of 12 divided by 0, you cannot simplify it further. You can only say it's undefined. Okay? It's kind of an interesting question. Okay, so data. Data is simply information, often numbers that you receive when we're talking about data here. Even data in, obviously in science projects, science fair projects, you'll gather data and then you'll use it to draw some conclusions. So today we're going to talk about some ways that we can analyze data, and one of them is to find the mean. So you're right, to find the mean is to add all of your data up and divide by the number of data that you added. So you've been doing this for some time. Add the data, which another way to say that is the sum of the data, and then divide by the number of data. So let's find the mean of this set here. I'm going to erase this because it was just the name of the problem. The difference this year in 7th grade is that we're so into integers that we're actually seeing a lot of negatives even in sets of data like this, right? So we're going to use what you've been practicing, adding positives and negatives, and we still use the same process to find the mean or the average. So do it, find the mean. You're going to add the numbers 16, negative 16 plus 17 plus 8 plus negative 23 plus negative 31, and then how many pieces of data are there? Yep. 5. We're going to divide that by 5, and we'll have our mean. Okay. We just learned yesterday something about the properties of addition, and one thing you might do is use them right here. I mean, how many of these pieces of data are negative? How many? 3. So we might just add those together first and add the 2 positives together somewhere else, right? We can take negative 16 and put negative 23 near it and put negative 31 near it and kind of group those together, right? And then take those 2 positives, 17 and 8, and kind of do them over here, and then add these 2 together later. So moving negative 23 over here is using what property of addition? When you move an addend. Remember, it's like you move from home to school. What do you call that? Begins with a C. Gavin? No? When you move addends. What do you call it when people are driving on the freeway or whatever? Huh? No? It was a word we used the other day. Colin. Brian. Aiden. Commutative. Everyone say it. Commutative. You just commuted them. Like taking a car, getting in a car and driving downtown. You're commuting. Or driving to school. So we commuted negative 23 and negative 31. And we're kind of using associative property. We're grouping these, aren't we? So that we can make this addition a little bit easier. So when we add now all of the negatives, we have what? Has anyone added them? What did you get?
Negative 45.
Who agrees? Negative 45? You agree? Okay. So are you sure it's negative 45? Because when I add these ones, I have 6 plus 3 is 9 plus 1 is 10. 0 carrying the 1. 4, 5, 6, 7. I got negative 70. Did anyone get that? Negative 70 for just those negatives? Emily?
I did it and then I added everything like on my calculator and I got negative 45.
Well, you know what?
I got 45 too.
I asked this question, and maybe you're not listening. I asked, what did you get when you added the negatives? And it seems like you're giving me the total when you added everything, doesn't it? That's what I'm hearing. So be careful with your listening, right? I think you should have probably negative 70 plus 25. And now, when you add these two together, do you get negative 45? Yeah, that's what happens. Okay, so we say negative 45 over 5. And here's the division we're talking about today, right? So what is negative 45 divided by 5? Everyone?
Negative 9.
Equals negative 9. And there it is. There's our mean. 10. And you may begin this assignment.
So when you check your